Cool. So, hello everybody. My name is Thomas. Thank you so much for coming. It's super exciting to finally have an event in person. It's actually my first event speaker and my first event as a Googler. I joined Google during COVID, so it's cool to finally be able to speak in front of a live audience. So I'm like Paul. I'm going to also talk to you about machine learning today, specifically on Android. I'm going to talk to you about two other platforms that Google has been working on for ML on Android. So I'm going to talk about pretty much everything Android ML except MediaPipe. We'll talk about TensorFlow Lite and on Android and ML Kit. It's gonna be a little bit high level, and I'm not gonna show you a lot of code. If you want to discuss about specific code questions and issues that you have, please come to me after. But I keep it as high level as I could while covering as much ground as I can. But again, if you are facing some specific issues with ML on Android, I'd love to hear more about it. So let's start with, and I know that Paul already did that, so I'll go super quick on that, but let's try it with kind of like a high-level presentation of ML. What can you do on ML that you basically couldn't do before ML was introduced, or cannot really do if you have to actually like code the whole solution? And then we'll talk also a little bit about ML on device and the benefits. And then I'll do a high-level presentation of ML Kit. Quick show of hand, actually. How many people here know ML Kit or have used it in projects? Cool. All right, that's perfect. So a few people, but not that many people. So I can speak more about that and show you what you can do with it. And then after that, we'll talk about custom ML, which is something that I actually work on at Google. I forgot to mention, by the way, I'm in the Android team as a developer relation engineer. And I'm working right now with the Android machine learning team. And so I'm mainly working these days on custom machine learning, so I'll tell you a little bit more about what custom means here. And so basically what we are using is mainly TensorFlow Lite. Who here is familiar with TensorFlow Lite for Android? Cool, so a little bit more people, but yeah, that's perfect. So I can tell you more about that, and if you have some very in-depth questions, please come talk to me after. So what can you do with ML? Feel that Paul covered a lot of that before, but basically you can group that in three categories, especially when it comes to like running ML on your phone. So you can do image-related applications, you can do text-related applications, and you can do audio-related application. And it's a little less common. Usually, a lot of the use cases revolve around images, but there are also text that is very common these days. Everybody is talking about ChatGPT, so obviously text is a big part of machine learning. And audio is something we don't necessarily think about, but we all have assistants running on our phone, whether it is Google Assistant or Siri if you are with the other guys. And so those are actually like obviously very prevalent use cases of machine learning. So, and I guess just to delve a little bit more, and I'll talk more about it in a second, but images, there is image classification on one end. It's like you take a picture and basically we tell you, okay, we think this picture is in this class, and you kind of like predefine the classes in advance. And there is also image object detection that is very different, where I think it's the example that Paul showed before, where you're basically going to identify a specific object on a picture. Sometimes we tend to like confuse those two cases. That wasn't super clear to me before I started working on ML. So those are honestly a big part of the ML applications that you see today on device. But there are other things like style transfer, for instance, when you have like a picture of one type and you basically want to use the same style of the picture in a picture that you took yourself. And for the text, there is text classification. I'll talk a little bit later about, for instance, the toxicity detection. So if you want to basically make sure that your content is actually doesn't have like profanity or anything. Unfortunately, in the world where social networks are kind of like everywhere, that's actually pretty useful to know, okay, is it a command that I want to kind of like let through? That's a good application of machine learning. And same with translation, right? We are all using Google Translator occasionally, so translation is a huge use case for machine learning. One thing too worth mentioning, so yeah, I talk about speech recognition for audio. Audio classification is actually really cool. I don't know if you are into bird watching. I wasn't before COVID, and I guess when COVID happened, we all found ourselves stuck at home. So there are actually really good applications that run on device that are good at detecting and recognizing the noise of the birds and tells you, okay, this is this type of bird. So there is the Merlin app. If you don't have it, you should definitely check it out. That's a lot of, actually I think some of the models are open source, so you can even build your own app yourself if you want to. But yeah, that's a cool example of audio classification. So I guess I kind of like started talking about those use cases. We'll see a little bit later how you can make it work. But for instance, for the case of image classification, so Paul talked a little bit about what you can do with MediaPipe. You have actually an example here of like image classification, and it's actually coming from a GitHub repo. So if you want to try it yourself, the TensorFlow Lite Android GitHub repo has a lot of those examples. And you can see here that it goes from like the coffee mug to the cat, and it's actually pretty specific. It says it's a Persian cat. So that's a good example of image classification. So you basically look at the items that are on the picture, and you basically try to categorize the image based on the items that you find. And you can see that there is a value next to the labels, and so that's kind of like the indication of confidence of the picture. So it tells you that it thinks that it's a Persian cat, but it's only 20 or like 15%, something like that. So anyway, that's basically what machine learning enables you to do, and you can do that by coding it yourself, and I'll talk a little bit about that later. Or you can use ML Kit that actually comes with like a few kind of like pre-packaged solutions to do that, and it's honestly just a few lines of code if you want to integrate that in your Android app.
Can I add something?
Yeah, question, yeah.
In the prior presentation, there was a square around the object. The square is not here. Is that the variable? That's configurable?
Yeah, great question. So that's actually the difference between object detection and image classification.
Oh,
so
image classification.
Yeah, and here it's classification. So it basically shows you 3 classes, and it's something you can decide. You can have like the top 10 classes or whatever, but that wouldn't make too much sense. You would get a lot of noise. But here it shows you like the top 3 classes that the machine learning algorithm is detecting on the image. What you are mentioning is object detection, where it shows the box and tells you, oh, there is a person right here and there is a cat right there. So that's basically the second example, and I say here is locate instances of objects on an image or on a video. And there is also image segmentation, which is also a cool use case of machine learning. I think if you've been using Google Meet or you've been using Zoom, you have those kind of like virtual backgrounds that you can add in the back. So basically you as a subject, you kind of like remain visible, but whatever is happening behind is kind of like hidden. So that's actually using image segmentation technique, where we can basically identify a region and we say, this is the person, this is the background, and it kind of like defines basically which region and where it stops, and you can replace the pixels by something else. So image segmentation is a cool example too of image application of machine learning. Then there is text classification. So as I said, for instance, you can so you are able to like assign categories. So you can say, for instance, the categories can be everything from like, I don't know, poem or literature or like some technical documentation. So you can train a model algorithm to say, I think this text is this class. But as I said, it's very useful for like text toxicity, for instance, applications. Or if you are using spam, for instance, a lot of the spam filters are not heavily relying on machine learning for text. And I guess, yeah, translation, I think at that point everybody has an idea of what translation, automated translation means. So we are pretty familiar with those use cases. Text prediction is actually pretty interesting. So at the end of the day, those large language model, and we're not talking too much about it today, like I'm talking about Bard from Google or ChatGPT from OpenAI, those large language models are kind of like giant text prediction applications. They are not yet running on mobile, but that's going to happen, I think, sooner than we think. It's still very complicated today from a technical standpoint because they are huge models, but we can see that happening. Again, I think it's going to happen way sooner than we think. So yeah, I don't know. I don't have a ton of information, but I think it's going to be in a year, but if it happens before that, I wouldn't be completely surprised.
When you say large models, how big are they?
I forgot exactly, but it's like billions of parameters, so that's several gigabytes basically. And so having that running on a device, it's complicated. I think there are some effort to like not necessarily run the latest and greatest on your phone, but I think some models already start running on your phone, but it's still very experimental. But one cool example, for instance, is the Smart Reply. That if you are using the Messenger Android application, for instance, you have that where you have like chips basically that are kind of like suggesting replies. If you are using Gmail, you also have it. So this is text prediction basically. They are obviously way simpler models, but they are still pretty cool. And I'll talk a little bit about ML Kit later. You can get those features in ML Kit today with just a few lines of code. Yeah, actually on the side right here, you can see like a snippet of code. So I use that as illustration, but I'm gonna stop on that for a second. This is relatively simple code, but for instance, if you want to implement translation, that's basically pretty much like the amount of code that you need to implement translation using ML Kit. So ML Kit is really meant to be pretty easy to integrate, even if you don't have machine learning expertise. I'll talk about that in a sec. And yeah, so audio classification, I didn't find an illustration for that, sorry. But two good examples that comes to mind is the audio classification for analyzing basically a sound and being able to say, oh, that's a dog barking or that's a car driving. So you can implement that pretty easily. And speech recognition, so this one is obviously pretty common, identifying the words that are spoken. So we've been using that. We've been like dictating our text, or I've been dictating my text at least for a long time. But yeah, that's actually a pretty common use case today. That is definitely based on machine learning applications. So why machine learning on device? I know Paul already talked about that before, but I'm going to reiterate here because you might think, okay, well, I have a model, I can put it on the cloud and create an API around it and make the device call this API and it's going to work just fine. There are actually a few cool benefits of running the actual machine learning inference directly on your device. The first one is the low latency. You want to have something that is pretty quick. If it has to do a round trip to the server and come back, it can be relatively quick if you are in like a dense urban area, but if you are further away, if you are, I don't know, in the countryside or something, that can actually get a little bit on the way on like a very seamless experience for your users. And depending what you are building, that can be actually pretty detrimental to the user experience. Then keeping the data private on the device, right? You don't necessarily want to upload all your pictures, and I don't know if you had a chance to try Lensa. Who is here is familiar with Lensa or the magic avatars? No, it doesn't. Yeah, a few people are checking that. Yeah, it's pretty cool. You basically upload a lot of photos, and they are going to like create those kind of cool comics or anime, basically pictures of you. And you can like use them as an avatar for your social network, for instance. It's not extremely groundbreaking, right? It's not gonna kind of like change the world, but it was kind of like a cool experience, and I used it myself. The problem is that they are asking you to upload a lot of pictures of yourself to their server, and then they run the machine algorithm on their server, and then they return you the pictures. It took me a while to actually like kind of like go ahead and doing it, and I can see how some users are like, actually I don't want to share like 50 photos of my face for you to run your algorithm. Maybe I should have not done it, who knows, but too late. So they are doing it for your dogs, by the way, right now, so if you are interested trying out, it's pretty interesting. So yeah, keeping your data private is definitely a good pro of running inference on device. Then working offline, right? It's also important for you to it can be important for you to use your application even when there is no server, there is no network connection, network connectivity. So running the inference on device helps you do that. And then if you are an app developers, honestly, I mean, at Google, we are very happy to take your business, but running machine learning on the cloud can get pretty expensive. It's pretty heavy process. And so at the end of the day, it's if you want to scale, it's going to cost you some money. If you can manage to change the model and shrink it to have it running on device, you won't have to pay basically the cost of the inference on the cloud. So that's also a good reason to try to run it on the device. And so some good examples. So here we have this pose detection algorithm that can be used for multiple things. So I think Paul was demoing the hand recognition detection algorithm, which is slightly different from this pose algorithm. Here it's for your whole body. But let's say you are a fitness application and you want to track the reps of the person that is working out. You can use this algorithm and running directly on the device. And for instance, here, the idea of like uploading the video feed live or like streaming live to a server to process it on the cloud and then returning the result, I think that would be pretty complicated and definitely expensive. So that's a good example of something you want to run on the device. Same with augmented reality filters, right? If you are using like Snapchat filters or Instagram filters, it would be probably impossible to run that. I should not say impossible, you can always do it, but running it on the cloud doesn't make a ton of sense. You need to upload the video and then get the result back and kind of like play with the latency. This is a good example of something that you want to run 100% on the device. So that leads us to two options. So Paul was talking about a third option, but I'm going to focus on ML Kit and custom ML. So if you want to run machine learning on Android and you don't want to use MediaPipe, you can use ML Kit, which is very optimized for mobile. It's production ready, and it doesn't require machine learning expertise. So if you know Java or if you know Kotlin, you can go ahead. It's going to feel very familiar, and you're going to have access to a lot of use cases that I'm going to cover later. If you don't, if you do know machine learning very well and you want to heavily customize the model, you want to have a total control over the performance, the user experience, then you can use the basically custom machine learning stack, and a big part of it is TFLite, and I'm gonna detail that in a second. So as I said, ML Kit, you don't need to know machine learning. Oh, actually, I reused the snippet right here, so here it is again. Everything is kind of like oriented for Kotlin and Java developers. So in the case of like the translation, for instance, you create an instance of this English to Spanish translator, and you just call translate on it, you pass the text, and you basically have a callback when it succeeds. And if it fails, you also have the callback, and it gives you the exception that occurred. So, and I'm obviously skipping a little bit of code, but there is really not that much more than that. Like the crux of it is there. You need to obviously instantiate the translator, and you need to make sure that you have like the right Gradle imports in your Gradle configuration. But yeah, so that's obviously way simpler than having to like create your own model, training it, etc., etc. Yes, and so I picked an example that was relatively simpler. Obviously, if you deal with, that was the example of text, so you just like pass a string as a parameter. When you deal with images, it can get a little bit more complicated. You want to make sure that you have the proper rotation, etc., etc. But it's relatively accessible and it's very well documented. And so the features that are offered are pretty large. So there is the selfie segmentation that I was talking about. You have some face detection algorithm. You have the pose recognition algorithm that I talked about before. Barcode scanning that is pretty handy during COVID and for a lot of other applications. So all of those features are available via ML Kit, and they are pretty simple to set up. And then there is, we have two categories: the vision aspect that deals with basically images, and there is natural language. it can be confusing. It's not speaking, it's not sound, it's actually text. But yeah, there is the language identification feature that tells you, I think there's a list of like, I don't know if it's 50 languages or something like that, but tells you what is the language that is used in the text that you're passing. Smart reply, which is pretty cool. Translation feature that is available. Entity extraction also is a good one. It enables you to extract basically some an address or a phone number from a text, so that can be pretty helpful. And as I said, so it's optimized for Android and it's production ready. So for instance, if you've done machine learning, especially on Android or on mobile in general, you know that it rarely works the first attempt. You need to refine, you need to optimize your model, you need to test it. It's going to work on one device, but then you're going to have to test on another device or another OS, and then you're going to run into issues. So you kind of have to do a lot of like testing. Basically, ML Kit, the people at Google working on ML Kit are doing all this effort for you, so you don't have to do it. So you are pretty confident that it's going to work on pretty much any Android device that is supported by ML Kit. And also there is this idea of like either bundled, unbundled, or dynamically downloaded for the model. So if you are, I don't know, if you are concerned about the size of your application, you might not want to bundle the model with it. So for big models, there's the option of having it unbundled, which means that Google Play Services is gonna basically get it for you. And so basically your user is gonna install the app, and when he's gonna use it, when he's gonna need the model, then Google Play Services is gonna download with it. Or there is this idea of dynamically downloaded, and then it's actually handled by you in your application. But you basically use a lot of the primitives from ML Kit to do it. You don't have to actually make the API call yourself, but you basically are the one triggering the download of the model. So question?
Yes, in that context, are you also supporting version control, so version of the model?
So the model
would dynamically update the model if there is a newer version of the model available?
It's a great question. So if it's unbundled, I assume, I should verify that, but I assume that if it's bundled, it's going to be updated the next time you're going to build. If let's say the model is changed, you're going to have to rebuild your application to basically get the model. If it's unbundled, I suspect you're right. I think you are actually relying on Google Play Services, so they're going to fetch a new model automatically. And if it's dynamically downloaded, I'm actually not sure what behavior happens there. You might have to re-trigger the download, but it's not super transparent. This is not something that you will see, or we will tell you, oh, post detection released a new model, here is what you should do. That's something that is kind of like happens behind the scene, because to be honest, those models are not necessarily changing like, every week or so. Like things remain relatively static overall when it comes to models. Another question behind you. Thanks for the question.
So could you expand on the ML models are optimized for instance on Android point? Like, does it do any optimization towards the specific hardware that it's running on, like using hardware accelerators?
Yeah, it's a great question. We can talk a bit more about that, but to give you an answer super quickly, basically it depends on the model. It depends on the use case. For smart reply, the model is, I think, relatively simple, and you don't need to rely. It's text. I don't know the size of the model. I assume it's relatively small. You don't need to do a lot of optimization or use the hardware acceleration to run it. For post detection, on the other end, then that's where you need to handle video feed, and so in this case, that's where a lot of the legwork is done by the ML Kit team at Google, where they basically are going to say, we are going to run it on the GPU as much as we can, and we're going to test it for as much devices as we can, etc., etc. So, but all of that is completely transparent to you. As far as you are concerned, you are just running the post-detection algorithm, and you don't have to worry about, oh, it's running on an older device, I got to use the CPU, or oh, it's running on the latest and greatest, and there is a GPU available that I can leverage. Is that answering your question?
Right, so it's all handled behind the scenes, app developers.
Yeah, that's correct, yeah. Yeah, other question?
So when it's bundled, when they download the app from Google Play, that model is downloaded onto their phone. But if you have it unbundled or dynamically downloaded, then you have to have that Wi-Fi connection. in order to get that. So how does it affect the latency? Is there a big difference, or is it kind of like one of those things you have to weigh at one point?
Yeah. Yeah, it's a good question. Yeah, that's true. You don't want to, you don't want to find yourself where you need the model and you don't have network connection and basically you cannot download it. So that's actually a possibility. So it's kind of like up to you as a developer if you basically, and sometimes you have the choice, sometimes you don't have the choice. Like I suspect some models are bundled no matter what, and in some cases I forgot exactly, but I'm sure that in some cases you have maybe the 3 options available. So it's up to you to decide what do you want to do. Do you think you're going to find yourself in the situation where the users are going to need the model, but basically you won't have network connection at that point? If it's the case, maybe you can go with unbundled or dynamically, but you want to, as soon as the user starts the application, you probably want to fetch the model right away, or at least come up with what would be the best policy basically to fetch the model and make sure that it's available when it's needed.
And is it possible to cache the model?
Yeah, you can totally trigger the download initially. Yeah. You don't need to wait for the time you need it to actually get it available. So if you want to learn more about it, developers.google.com/ml-kit, and you have like a lot of documentation. It's relatively, I would say it's kind of like relatively easy to approach if you have a little bit of like Android expertise. Even if you don't know Android very well, like you have a lot of samples that are available. So I definitely recommend to play with it because it's actually pretty fun to build things with it. So that was the ML Kit side of the things. Should pay attention to the time. I'll try to go a little bit quicker. So the alternative, as I said, is kind of like the idea of custom ML. So I'm gonna talk a little bit about custom ML stack while staying pretty high level. If you want to talk more about it, please come talk to me, or even happy to like schedule a meeting or like a call after if you want to follow up. But that's kind of like a part that I've been working on a little bit on lately. So the idea of the Android custom ML stack is to tell you, okay, you know machine learning pretty well, you have a use case that is pretty advanced, pretty complex, you want to have 100% control over the execution, like pick which hardware you're going to execute the inference on, and basically we are building a set of tools, or a set of components rather, that are available to like make the process a little bit easier than starting from scratch, downloading TensorFlow-Lite and building it from scratch basically. So I guess good examples of applications are, for instance, just for context, when I say when do you actually want to have a lot of control over not only the execution but also the inference. So LensAR Translate that was actually announced a few weeks ago is pretty cool. You can see here, it's going a little bit quick on the GIF, sorry about that, but you can see that it takes the text in Spanish and converts it in English, and it not only converts it, but it also like adds it on the image, and it kind of like predicts the pixels that were before hidden by the text in Spanish. I don't know if you can see. So all of that is actually directly running on the device. So we look at the picture and we kind of like assume what are the pixels behind, and we kind of like add the translation on top of it. If you want to do that, you need to have control over a lot of things. You need to make sure that the latency is relatively reasonable. You want to make sure that if you have limited processing power, you might not generate or predict the pixel with like the same level of detail than if you have the latest device, etc., etc. So all of those things are basically things that are pretty hard to do if you don't have a full control over the whole process. Another good example is Magic Eraser. So I don't know who is familiar with Magic Eraser in the room? If you have a pixel, I guess now it's available on other devices too, but if you have a pixel, you should definitely try it. It basically lets you remove some unwanted, so it's up to you to decide what is unwanted, but some unwanted objects on the picture. So you can see here that there is a little girl that is like facing the ocean, and there are like people kind of like blocking the view, so you can basically remove them. I think there you go. You can basically remove them from the picture, And so it's the same thing. You need to like identify what is potentially seen as like unwanted, because the app is going to suggest you something that can be removed, and then it's going to kind of like create this cool effect where those people kind of like slowly fade away. So all of that requires you to have like some level of control that is pretty advanced on the process. This is not something that ML Kit is going to give you. You need to basically be in full control. So coming back to the Android custom ML stack, what it is. So there are like three main components today that we have. So first of all, TensorFlow Lite. TensorFlow Lite for Android is open source. You can download it, you can build it yourself, and you can get a pre-built version via Gradle. Basically, you update your Gradle imports, and you can bundle it in your Android application. We kind of like realize that basically if everybody does it, you kind of like duplicate a lot of code on the phone that doesn't need to be duplicated, right? You need one version of TensorFlow Lite per Android device. So if you have 5 applications that are using it, it doesn't make sense to have 5 times TensorFlow Lite bundled to the app. So it was added to Google Play Services recently. So that means that you can basically, you build your application and you say when you need to do machine learning inference, you talk to Google Play Services and say, oh, give me the latest version of TensorFlow Lite. So this way you save some binary size. I mean, you reduce the binary size on your application, and you are also running on the latest stable version of TensorFlow Lite too. You don't need to like rebuild, redeploy, and have your users re-download the application to run on the latest stable version. And another thing too is that we actually are very committed to make it like the official machine learning inference engine. So what it means really is that a lot of like new features that are going to be added will be added in TensorFlow Lite in Google Play Services. Question?
Yeah, what kind of delegates are available in TFLite services? Like CPU, GPU, TPU, DSP?
Yeah, it's a good question. So I actually have a slide about that, but I can answer. I mean, I have a slide on delegate acceleration right after. But to answer your question, today GPU is supported via Google Play Services, so you can use the GPU delegates that's supported. You can also use the NN API. So if you look into TensorFlow Lite on Android, you're familiar with it. The neural network API delegates that is not packaged via Google Play Services, but it is part of TensorFlow Lite on its own. So you also have access to that. And the NN API, and if we can maybe talk after about it. I'm curious what's your experience or the challenges you are running into. We are aware that it's not fully perfect yet. We are like working on improving it. It gives you some support of some TPUs and some DSPs, but it's definitely not as comprehensive as the GPU delegate. But that said, we are working on it, and the goal is to basically have all the delegates available to you for all the new chips that are shipped by vendors. It's very complicated because Google makes a very, very fraction of chips, but if we want basically other vendors to support this, we need to talk to MediaTek, we need to talk to Qualcomm, and it takes time. So hopefully at some point we're going to get there. Today it's not perfect, but GPU today the support via delegates is pretty solid. So that's me. So I made actually a video on TensorFlow Lite in Google Play Services. So if you want to learn more about it, there is more code there and there is more details. And I'm realizing that I'm running behind, so I'm going to try to accelerate a little bit.
No worries.
Okay.
Take your time.
Okay. So we just talked about the delegates. So that's kind of like the second brick, right? The second component that we built. So if you want to let's talk a little bit about hardware acceleration actually, because maybe not everybody is familiar. Machine learning is a pretty heavy process to run, and very commonly on Android initially, you kind of like run all your process on the CPU, except if it's some graphics, and then you basically are running it on the GPU. And a lot of that, as a developer, and it took me a while to really understand how all those things work, as a developer, when you create an application, you don't really think about those things. You just build your application and you give it to the device, and the device figures it out where to run it. The thing is, for machine learning, actually there is an interest in knowing, okay, am I actually going to run that on the CPU? What if I can have access to another specialized chip? So DSP, the digital signal processor, which is usually used for the voice, for instance, conversion. When you want to convert some analog signal into a digital or digital to analog. Turns out it can be pretty cool actually to use this chip for machine learning. It has a lot of parallelization capabilities, and it can be pretty good, but it's not always good. Sometimes some machine learning algorithms are actually not running very well on DSP. So that's when basically you want to test things and try to see where is the best way to run your inference. And there is a component to help you with that I'm going to talk about right after. But so long story short, sometimes you build your application, you run your machine learning algorithm, and you try it on CPU, it works okay, and then you try it on the GPU and it's 10 times faster. So that kind of makes you realize that, okay, maybe using the GPU is important. So that's where you can use the GPU delegate. So the GPU delegate is available via Google Play Services. So there is basically an extra Gradle command line that you need to add to basically add the support. It's pretty well documented. It is actually kind of what Google recommends you to do if you want to use the GPU. Just use the delegate. We are basically figuring out the conditional logic basically of when it's going to work versus not. So just use the GPU delegate. And we also tested it for your device. So we can tell you, okay, this device, we tested the GPU, given your model, it should be fine. Just go ahead and use it. So yeah, that kind of prevents you from bundling a driver for each GPU that you know about, and you might not know about all the GPUs, and kind of have the conditional logic implemented yourself. And as I said, there is more hardware configuration to come for other delegates. Today it's still a little bit of a work in progress, but it's gonna hopefully happen soon. And I also made a video about hardware acceleration. So there is a link right here. I'll try to share the slides at the end so you can have all those links. But there is the developer.android.com/ml landing page that has a lot of information that you can find there. And so the third component is the acceleration service. So this one is pretty new. It's actually currently in private beta, but we've been talking about it for a little while. And so the idea of the acceleration service, so it's not a service that is actually going to accelerate your machine learning inference, but instead it's a service that's going to tell you what is the optimal hardware configuration on the device that you can use for your model, and we do it at the runtime. So it's for the device you are currently running. And I think it's a pretty interesting strategy. It's very hard even for Google to say, oh, given your model, we think you should use this chip for this device. Even Google, we kind of gave up, to be honest. We're not going to have a farm with every single Android device and run some benchmark on it. We have a very large farms to run benchmark, but there is always going to be a device that we don't know about. And so the idea is to kind of put that in the hands of the developers. And so the acceleration service, you can look at it like that. So it's it actually lives actually, sorry, I'm thinking. No, it does. It lives in Google Play Services. So it's another example of something that lives in Google Play Services. You don't have to bundle it with your app. You can fetch it from Google Play Services. So it basically has an API that takes your model, takes golden samples, right? You basically pass some sample data and the expected result. So for instance, the cat we showed before, you basically pass a picture of the cat and you say, okay, the label or the class that should be returned should be cat. And you pass a few sample and a few expected results. And then we basically have an internal benchmark that is going to run it. So at the moment, it's only testing CPU and GPU, but eventually we're going to add DSP and NPUs or the TPUs on. By the way, NPUs means neural processing unit. I should have mentioned that before. It's a chip that is dedicated to machine learning inference. And so on the pixels, for instance, we call them TPUs, but that's pretty much the idea of a chip that is dedicated to run machine learning. And so we have an internal benchmark that's going to test your model on all those chips and tell you, okay, we think in this case you should go ahead and use the GPU. So again, right now it's just CPU and GPU, but we are working on adding more chips. You might say, well, why not always use the GPU? Well, it turns out sometimes the GPU, first of all, there are always errors, and sometimes you're going to try on the GPU and whatever operation that you are using in your model is not supported well on the GPU, and so it's going to not work well, it's going to crash, and so just stick with the CPU, it's better. But sometimes there is the case where some operations are not supported, and so your model is going to be kind of like split between CPU and GPU and going back and forth. This is not ideal. Like, you want to stick with one chip, and so if it has to run some of it on the CPU, just run everything on the CPU. So the acceleration service is going to be able to do that for you, give you some feedback, and for the specific device you are running on, tell you, okay, use this configuration. And so this way, as a developer, you don't even have to worry about it. You just run the acceleration service, you get the feedback, and you pick whatever configuration is written by the acceleration service, and you know that it's basically the best acceleration configuration available for you on the device, specifically for your models. And that's where it's very important. It's kind of like your model that you build, and so it's very specific to your model. So that's still in private beta. If you are interested or you have use cases, come talk to me. I'm happy to see how we can give you access to it. And it's something we are pretty excited about. So I kind of walk you through the 3 components almost at the end of the presentation. If you want to try testing models, you don't necessarily have to create the model from scratch. You can go to tfhub.dev. That is basically a model repository. So if you're not, some people are familiar here of tfhub.dev, no? A few people, okay, cool. Yeah, so it's pretty cool. I mean, you can look at it as GitHub, but for ML basically. So you can get some models, you can retrain them. Some models are very bare bone. There is pretty much zero explanation, and some are super in depth. Tells you how you can retrain it, show you how you can very easily integrate it in your Android app. So it's a good resource if you are basically trying to get your feet wet with ML custom machine learning. And so as I said, a lot of what I talked about is not necessarily fully documented, but you have entry points and links and starting points on d.android.com/machine learning/ml. Sorry. I would recommend you to start there. And if you want to reach out, that's my Twitter handle and my email address, so feel free to email me. And that's it. Do you have time for questions or not at all?
Yeah, sure.
I don't know if there are questions. Yeah.
Can you maybe talk about some of the differences between ML Kit and the MediaPipe that we just heard about? Especially, I noticed there's some overlap with the models that come packaged with those.
Yeah, it's a great question, Paul. I don't know if you want to jump on it. It's
So the MediaPipe is able to put in their own models, which kind of makes a big difference out of it. The ML Kit itself is also built a decent amount on top of MediaPipe. So the pose detection one that I showed is the underlying framework that's being used by ML Kit. So you get a little bit more control over a lot of the same efficiencies with it.
Okay, so at least some of ML Kit is built on top of.
Yeah, so ML Kit, a good chunk of it is built off of MediaPipe, but MediaPipe has a little bit more customization to it, whereas with ML Kit, if you just want to throw in something that pose detection, you don't care about the models and then you're there doing all the extra making sure it's going to work at the very best at what it can do, then you use ML Kit.
Okay, so is that, are you talking about just the API or the models themselves?
So the models themselves would be, ML Kit gives you the models. For us, you can put in your own model, you can find a different one, but they're not guaranteed to be optimized for that device because they can be custom done or it's block for blocks.
Yeah, it's kind of, if you want some flexibility, but you're still starting and you don't feel like going all in and using custom ML, MediaPipe is kind of a good in between ML Kit and custom ML. But I understand your question, and I think our answer is addressing some of it, but we probably can do a better job at making sure that things are better positioned. Yeah.
I appreciate this. Thanks.
I think there was other questions. Yeah.
So you wanted to start with ML Kit because you're not proficient in machine learning and it scares you, but then you get really good at it and you're coding, you have certain things you want to change that doesn't currently exist in ML Kit. How hard would it be to move to TFLite? And would you have to refactor your entire code, or is it like?
Yeah, I would say that basically if you exhausted ML Kit, maybe you want to use that media pipe because that's kind of like an easier transition to, giving you some flexibility. But yeah, to be honest, I think ML Kit, it's very easy to do, but it's also like relatively rigid, right? Like you can't. There are actually, I think, for object detection, you can replace the model, right, on ML Kit.
From my perspective, I feel like sometimes it's not as easy. Because I did give feedback myself.
On ML Kit?
Yeah, like if you're writing code with not ML Kit versus using ML Kit, I think you would have to change the code.
Really? Okay.
Yeah, so the full refactor, then you'd be like, okay, let's start from scratch.
Because when you use ML Kit, you have to use the ML Kit methods.
Yeah, I see. Yeah, you mean the callbacks and everything?
Yeah.
I mean, that definitely requires you to change your code to basically like include it. But I would still, I'm happy to follow up and talk about it. I still think that a lot of, ML is pretty complicated, right? You have to like handle a lot of edge cases and everything. The benefit of ML Kit is that you call the method, you pass the parameter, and you get the response in the callback. That's when you get to that point with custom ML, that means that you already did a lot of like the groundwork before. Like it takes you a while to get there.
Yeah. Although it's easier though now with the task API or media pipe, it is easier. Back a couple of years ago,
That's true.
a long time ago, you have to write a lot of code, pre-processing and post-processing, and versus ML Kit is very different.
Yeah,
But
that's
now
true.
they're going, yeah.
Yeah. Cool. All right. Well, yeah. Thank you. Thank you, everyone.